Hey guys, I wanted to do a little video today on my Miss Pac-Man board. I had replaced the 50-watt power resistor with two resistors put in series. One of them being a 1 watt, the other one is a 5 watt. I think one was 33 ohms, one was 18 ohms. And I was incorrect in what I was thinking about how I know resistors, you put resistors in series and you just add the resistance. You know, if they're in parallel, you divide the resistance. And I was, for some reason, just thinking automatically, okay, well, I'll put a 1 watt and a 5 watt in there and it'll be 6 watts of power dissipation. And it was correctly pointed out to me that that is not right. And I had to rethink it and kind of restudy it a little bit, and I'm like, yeah, okay, the power that goes through the circuit is the same for all of the resistors in the circuit, so they each have to be able to handle that wattage that is going through the circuit. So I thought I would take the time here to just document, do a little bit of an educational thing, a little bit on just, you know, Ohm's law a little bit, and on this Pac-Man board, kind of a real world using Ohm's law in a Pac-Man board, which is kind of cool because, you know, you learn about Ohm's law and stuff, and you don't always get to use that kind of stuff. So I thought it'd be cool to just kind of show that. So that's what I'm going to do. We'll take a look at the schematic first, and we'll look at the board and see my mistake and what I did. You know what I did, but we'll take a look at it and see if we can't figure it out. That's the resistor right there that I put into this board. And you can see what I did here. I have a 33 ohm and an 18 ohm. And making the 50 ohms because my resistor opened up basically that was in here. So I was like, well, I'll put a 1 watt and a 5 watt in there. And I was thinking that would be good. And you know what? In a pinch, if you're just running this, you turn it on, you're playing a game, you turn it off, that's no problem. This would be fine. But if this was going to like an arcade situation where you're turning a game on, leaving it on 8-10 hours a day, this right here would eventually fail. That guy right there would burn up eventually. And we'll look at the schematic and go over that circuit right there, and we'll do a little bit of measurement, get some ohms and what the voltage is, and then we'll do some math on paper, and we'll find out what the power rating going through that circuit is, and then I'll show you how that would not cut it. Okay guys, I got my Pac-Man schematic out, and we'll see here we have, this is that section right here. There's our 50 ohm 5 watt resistor. So we're going to measure, first of all, I want to get this value, exact value of this ohms, and then I'm going to get the exact value. I'm going to measure voltage from this point right here after this diode to ground. And I'm going to get the actual voltage going over this resistor here. So let's do that real quick. Okay, the first thing I'm going to do is I'm going to measure the resistance across this guy, and how I'm going to do that is go from the cathodes of these guys and go to, let me look at the schematic here. Looks like pin 3 of this regulator, which 1, 2, 3 comes off and goes right here. And I am getting 51.1 ohms. 51.1. Okay, so I'm going to write down 51 ohms. 51 ohms. Okay, now I'm going to turn this thing on. I'm going to switch this to measure voltage. I'm going to turn this game on. Okay, and I'm going to measure from ground to, I forget where I said, from ground to that diode right here. And it is 11.01 volts. So 11 volts. 11 volts across that resistor. Okay, now we'll turn this off. Okay, now let me set this up a little bit. I will come back. All right, everyone. Well, we got our readings here, our measurements. We had 51 ohms over that resistor, over this right here. This total is 51 ohms. And the voltage across this guy was 11 volts. So I drew this little circuit diagram here, 11 volts, 51 ohms. So what we need to do is we need to find the current that is running through this circuit. And the Ohm's law formula for current, I is current, don't ask why, it's just what they use. I is V over R, which is voltage over resistance, or 11 over 51, which equals 0.216 amps, or 216 milliamps. Okay, so that circuit has 216 milliamps running through it. And now that we know the current going through it, we can find the power, the wattage that is going across that in that circuit. So we'll do power formula in Ohm's law is current times voltage, or 0.216 times 11, which equals 2.38 watts of power. 2.38 watts of power is in that circuit. So this resistor here has to be able to withstand 2.38 watts of power dissipation. And that is a 5-watt resistor, so that is perfectly fine. But what I have done here is this wattage that is running through here, that is being dissipated through this circuit, every resistor that's in here has to be able to handle that same dissipation. So this is a 1-watt resistor here. And you can see 1-watt resistor is not going to be able to withstand this 2.38 watts for long term anyway. That's why that has to be removed. And I have ordered the proper resistors. I've ordered a handful of 5-watt 50 ohm resistors to replace this guy with. And yeah, I'm really glad that was brought up to me, and I had to kind of go back to school a little bit. Yeah, so. But I thought it'd be fun to just kind of go through that. This is what's going on when you're talking Ohm's law and whatever. Real example here in a Pac-Man board. So that's it. I just had the idea. We wanted to go through that and kind of explain. Maybe someone will like that. Maybe someone will think that was cool. I don't know. But anyway, thanks a lot, guys, and I'll see you on the next repair.